second method is one-base indexing, where you start indexing elements from 0. N-based indexing is the third and final method of integer indexing, where user can select the starting index. Mostly used method in modern languages is zero-based indexing. But this method is little bit confusing since each element of the array has the index n-1. This is a diagrammatic explanation of the element and its index on zero-based indexing. Some languages allow user-defined strings to be used for indexing. These strings are called keys. We will discuss this at length when we discuss language-specific details of arrays. Multi-dimensional array can be thought of as array of arrays. Number of dimensions you can have depend on the programming language you use. This array shows how two-dimensional array may look when values are stored. Declarations of multidimensional arrays are similar to regular arrays, but we have to specify the size of each dimension of the array during each dimension. Example shows how two-dimensional array should be declared. Index of an element in multidimensional array contain no of digits equal to no of dimensions of the array. For an example, to access the element in three-dimensional array we have to specify 3 indexes. This is an example of indexing in a two-dimensional array. Parallel arrays are not actually another type or version of arrays. It is an interesting application of array data structure to store related information. It is very similar to a table of records. Each separate parallel array can be thought of as one column in a table and same indexed elements in all parallel arrays as a single record. As an example, let's take these 3 parallel arrays: name, age, city. Each of these represent the column in a table. Therefore these 3 parallel arrays form a table with 3 fields. Now let's move into the values stored in those arrays. If we group all the values under same index on these 3 parallel arrays, it forms a single record or row in the table. This slide clearly shows the above explained concept and how records are formed out of same indexed elements on parallel arrays. Let's consider record form out of index 0 values in parallel arrays. Here name Simon was stored at index 0 of name array, age 15 at index 0 of age array, and city Colombo at city array, and all of this group together form the record of a person called Simon, and his all information were stored in the similar indexes of all arrays. I hope the concept of parallel arrays are clear to you now. Our discussion of parallel arrays ends here. For loops and arrays. For loops and arrays have become inseparable components in modern programming. For loops are used in almost all operations involving arrays. Some of them are array initialization, printing, searching and sorting array elements. Number of for loops that have to be used in above operations depends on the number of dimension of the array. That means if we use one-dimensional array we only have to use single for loop, but if we use two-dimensional array, we have to use 2 for loops. Similarly, if array has n dimensions we have to use n number of for loops. This slide shows the usage of single for loop to initialize one-dimensional array. Here we use for loop to access array element 1 by 1 till the end of the array. For loop ends when last element of the array is accessed. This slide shows the use of single for loop to print all elements of a one-dimensional array. Similar to previous example, for loop is used to traverse through the array. Use of a for loop in an array sorting algorithm is shown in this slide. Utilization of for loop in array searching is shown here. Let's see what is a sparse array. In computer programming, sparse array is an array which contains identical elements on most of its indexes. Therefore we can say, array which contains default values or array which has been just initialized is a sparse array. They contain identical values in each array location. Let's move into another array-related term, that is array slicing. Array slicing is the process of extracting contiguous sequence of elements from one array and forming a new array. In some modern programming languages, there are inbuilt methods to do this. We will discuss that at length in second part of this video, when we talk about language-specific array implementation. Here the array slicing is shown in a diagramming way to make it very clear to you. But note that array slicing can be done from anywhere within an array, not only from the middle. Here we are going to discuss common methods involving arrays. These methods are normally implemented to ensure abstraction and promote code reuse. Note these methods are not library functions or language-specific. These methods are commonly implemented by programmers to make it easier to handle arrays. In coming slides we will